Hi guys, Daniele here. Today we're gonna talk about the out attribute, which is possibly the single most important attribute in the Bach library. Let's take a list in Bach style, so with some parentheses determining some levels of hierarchy in the list. This is also called LLL for list like linked list. And let's do something with it. It doesn't really matter what. In this case, we are reversing it, repeating it twice, and taking a portion of it. But at some point, we might want to print it in the Max console. And when we do, we're going to be disappointed because we just see bach.lll with a certain number. And even worse than that, the number keeps changing when we click the message different times. This actually tells us that what's passing through this patch cord is not the textual representation of the list, but rather a native representation of the Bach list. What do we do with that? And to answer that, we first need to understand why Bach needs to have native representations in the first place. And the reason is simple. Max lists are designed to be fast, but they are not as powerful as you'd think. They are limited in size, so by default, ZL objects only work with 256 elements. You can crank them up until 32,000 with some tweaks, but you cannot go farther than that. If you try 33,000, well, you get 32,767, which is the hard limit of the list size in Max. It's 2 to the power of 15 minus 1. And this is a problem because scores in Bach can be actually described by many more items than that. You can imagine to have many notes in many voices. Each note has many properties or metadata or envelopes and so on. You can easily go much beyond that. And Max lists are not designed for that. On the top of that, Max lists are not designed to handle hierarchy at all, whereas Bach lists do. When I send a message like this to bachrev, what happens is actually bachrev tries to figure out what I mean by using those parentheses and builds an inner representation which is much more like this, much more like a tree. This representation takes time to be built, and it's only done once by bachrev. All other Bach objects kind of rely on that expertise which has been developed, because what bachrev passes through this patch cord is not the textual representation of the list any longer, but by default the native representation of the list, so that it can be faster understood by Bach repeat. It doesn't need to repass it, and so on. The drawback is that print does not understand it. Print does not understand any native representation of Bach objects. It only understands Max representation or textual representation of lists. So again, Bach objects understand both the native and the textual syntax, whereas Max objects only understand textual representation of lists. Well, the advantage is that now we can build lists of virtually any size, like 100,000 elements or 1 million elements. And this is handled no problem in the Bach ecosystem. On the other hand, what if we want to use this kind of expertise developed by Bach, but we want to display it in a message, or we want to use it to drive some lines or any other Max object that does not understand Bach native syntax? Well, this is not going to work because neither the message nor line understand the Bach native syntax. On the other hand, there's the out attribute for that, and exactly for that. The out attribute is something that all Bach objects that output LLLs have. Any Bach object that outputs an LLL has an out attribute. And to set the out attribute, we can use a single letter, like in this case, or a string of letters. A single letter can be either N, to mean native representation, or M, to mean Max representation. By default, Bach objects output native representation. So there's no need of putting it like that. It's just like this. On the other hand, if you want the list to be readable by max objects, you need to put etoutm. This is gonna work for messages, and it's gonna work for lines and any other standard max objects. This is the general rule. There's one exception to that, is objects that control the flow instead of actually doing things, like gate or trigger or switch. Those kind of objects can deal with the native syntax without any issue. They are just taking it and letting it through. If you use trigger, for instance, with backlists, you want to use it with L. And this is gonna work, no problem. The native syntax is gonna be triplicated in this case. This is true for objects that controls the flow, but for any other max object, if you have a bach object above and you want to connect them, you need to use etoutm. This is kind of the golden rule. So why don't we use etoutm all the time? What's the drawback in using it all the time? Well, you can do that, of course. This is gonna work nicely for short lists and in these simple scenarios. You're not gonna notice any difference. But what happens under the hood is that bachrev is outputting a textual representation of data and not an internal representation, not a native representation. This takes time. And so you have time to deparse the list. And then again, bachrepeat needs to reconstruct the hierarchical representation from the textual one, and this also takes time. So we are actually wasting a lot of CPU time in this. And there's even worse than that. Here we are trying to collect 1 million numbers, each within a level of parentheses. Okay? So what happens is that bachcollect should output a list of numbers wrapped inside parentheses. But what happens is that if we tell bachcollect to use a max output style, well, a max list has a fixed limit in size, which means that after 2 to the power of 15 minus 1 elements, everything else will be trimmed. And what happens if the last element is an open parenthesis? This is gonna be an unmatched parenthesis. The syntax will not be balanced anymore, and bachlength will not be able to understand the message any longer. And this is exactly what happens. Bachlength complains that this is not a valid LLL. This is a bad input LLL. So don't use etoutm when you don't need to, especially if you have long lists. On the other hand, you really need to use it when you need to communicate between a bach object and a max object. In this case, this is a simple monophonic synthesizer. It's really simple, meaning that we are not handling any superposition of nodes or things like that, but this is still should work because we are taking the output of the playout, we are taking sense, velocity, duration, breakpoints, feeding them to bach.dl2line to build a line audio rate MIDI cent envelope of the pitch. Divided by 100, you get a MIDI, and then convert it into frequency to feed a cycle. This is gonna be our simple oscillator, and this is gonna be a way to trigger every note and to turn it off after it's done. But it doesn't work. Well, it should, but it doesn't. It does not work because it has a couple of issues. The issue is not the gate, because this is a bach object, this is a max object. It doesn't matter because it's just a flow control, so it should work. The issue is we have a bach module and we have a max object. Those two cannot communicate unless this module is put with etoutm. Notice that DL2line is not an object. It's actually an abstraction. It really doesn't matter. All abstractions that deals with LLL as output also have the out attribute. Any module in Bach does. This solves the first issue. There's still another issue. Here the duration is coming out as in native form. We are feeding, the trigger is not the issue once again, except for the fact that we cannot use F for the native form. As we said, we use L. But then again, delay does not understand the native form, so we have an issue here. What we want to do is to use max output for this outlet, and this outlet only, because we don't need max output for the others. We need for that. To do that, instead of using etoutm, which would put max max output on all LLL outlets. You can see it in the tooltips text when you hover with the mouse on the outlet. We use not just a single letter, but a string containing n, meaning the first outlet is going to be native, the second is going to be native, the third is going to be max, and then native. And then again, we can use f now, because it's going to be understood, it's going to be a float, and the bang is going to be properly delayed. And this is going to work. Okay. One last thing before leaving you. There's another option for the out attribute, which is @out t. T stands for text, and it's basically the same as m, except for one specific case. The case involves backticking. Backticking is a way in Bach to tell Bach that a symbol, some symbol, is actually simply a symbol and does not have to be parsed for anything more. This could involve parentheses or rational numbers and so on. For instance, in this case, if we send this to bachscramble thinks that those parentheses means that there's a hierarchy, whereas this is not true for us. That's just the title of a song. In order to tell Bach that that's just a symbol, a single one, even if it contains parentheses, we can either backtick or we can use the bach.textin object. In both cases, it's gonna work fine. Well, yet, if we want to have the backticks when we deparse the list, we need to use @out t. If we want to get rid of the backticks when we deparse the list, we have to use @out m. Again, m stands for max. Most likely you are not gonna want the backticks in max. There's a slight drawback in using m instead of t. If I then give this to my bachscramble will be happy and will understand it, no problem. But if I give that to bachscramble, well, it's not gonna be the same because there's no backticking, and so I cannot do that without again putting something inside bach.textin or putting the backticks by hand. Again, it's a very small difference, but that's pretty much the only difference between @out t and @out m. There's another option possible, which is @out p, but it's a very specific option that has to do with subpatches and abstractions, and we'll see that in a specific video. That's all for today. I hope this was helpful in some way, and till next time.